These are Calc 2 final exam solutions. Number 1, find the area of the region bounded by y equals x squared and y equals 9. So quick graph. We've got a horizontal line and a parabola. Find out where they touch. X squared equals 9, x is plus or minus 3. So integrate from negative 3 to 3 of 9 minus x squared. I'll take the integral from 0 to 3 and double it by symmetry. So 2 times 9x minus x cubed over 3 from 0 to 3. Plug in 0, you get 0. Plug in 3, you get 27 minus 27 over 3. 27 minus 9 is 18. 2 times 18 is 36. Number 2, so y equals x cubed. Here's my typical slice. Doing from 0, 0 to 1, 1. Verify that x cubed equals x. X times x squared minus 1 equals 0. X times x plus 1, x minus 1 equals 0. X is 0. There it is. 1. There it is. Negative 1 we can ignore for this problem. So volume is integral from 0 to 1. This is the washer method. Pi times x squared minus pi times x cubed squared. Take out the pi. X squared minus x to the 6. So pi times x cubed over 3 minus x to the 7th over 7 from 0 to 1. Plug in 0, you get 0. Plug in 1, 1/3 minus 1/7. So 4 pi over 21. Number 3, 0, 0, negative 2, 2, 4, 8. This is y equals 2x. Slope is 2. This slope is negative 1. Y equals negative x. This one, the slope is 8 minus 2 over 4 minus a minus 2, which is 6 over 6, which is 1. Y minus y1, y minus 8 equals m times x minus 4. Y equals x plus 4. So the area is integral from negative 2 to 0. The upper is x plus 4 minus the lower is negative x. And then from 0 to 4, the upper is still x plus 4, but the lower is 2x. So this becomes, see, 2x plus 4 from negative 2 to 0. This becomes 4 minus x from 0 to 4. So this integral is x squared plus 4x. This one is 4x minus x squared over 2. Plug in 0, you get 0. Plug in negative 2, you have 4 minus 8. Plug in 0, you get 0. Plug in 4, 16 minus 16 over 2 is 8. That comes out to be 4 plus 8, 12. Number 4, let u be e to the x. dv is sine x dx. du is e to the x dx. V is negative cosine x. We're integrating by parts. So the integral is negative e to the x cosine x minus the integral of v du, negative e to the x cosine x dx. Double negative, make that a plus. So I have negative e to the x cosine x plus I1. I'll call this I1. I1, u is e to the x, dv is cosine x dx. Du is e to the x dx, v is sine x. So I1 is uv, e to the x sine x minus the integral v du, e to the x sine x dx. That's the same as I. So I1 is e to the x sine x minus I. So I is negative e to the x cosine x plus I1. And here's I1, e to the x sine x minus I. Add I, 2I equals, factor out the e to the x. I'll write it as sine x minus cosine x. So I is e to the x divided by 2, sine x minus cosine x plus c. Number 5, change cosine cubed to cosine squared times a cosine. Change cosine squared to 1 minus sine squared times sine squared cosine x dx. So let u be sine x, du is cosine x dx. This becomes 1 minus u squared times u squared du. Distribute u squared minus u to the 4th. So that's u to the cubed over 3 minus u to the 5 over 5 plus c. Plug back in for u. 1/3 sine cube of x minus 1/5 sine to the 5th of x plus c. This one, partial fractions, split into a over x minus 5 plus b over x minus 6. Multiply this fraction by x minus 6 over x minus 6. This one by x minus 5 over x minus 5. Here's my common denominator. Distribute the top, ax minus 6a plus bx minus 5b. Combine like terms, a plus bx plus negative 6a minus 5b. That's equal to negative 1 times 8. So I have a system of equations. A plus b is equal to negative 1. Negative 6a minus 5b is 8. Multiply this equation by 6. 6a plus 6b equals negative 6. Leave the second one alone. Add them up. B is 2. Plug back in for b, and a is negative 3. So I have the integral for negative 3 over x minus 5 plus 2 over x minus 6 dx. I'd like to write the positive first. So 2 ln absolute x minus 6 minus 3 ln absolute x minus 5 plus c. Number 7, y equals radical 36 minus x squared from 0 to 6. You have a quarter circle. Circumference is 1/4 of 2 pi r, 3 pi. So the answer should be 3 pi. dy dx is 1/2 36 minus x squared to negative 1/2 times negative 2x. 2 cancels out 2, negative x over radical 36 minus x squared. 1 plus dy dx squared, 1 plus square this, x squared over 36 minus x squared. Common denominator, 36 minus x squared. Add them up, x squared cancels out. 36 over 36 minus x squared, divide top and bottom by 36. 1 over 1 minus x over 6 squared. So the arc length is the integral from 0 to 6 of radical 1 over 1 minus x over 6 squared dx. That u be 1/6 x, that's the same as x over 6. du is 1/6 dx. So I need a 1/6 inside and a 6 outside. Change the limits of integration. When x is 0, u is 0. When x is 6, 1/6 of 6 is 1. So my new integral, the length is 6 times integral from 0 to 1 of 1 over radical 1 minus u squared du. That's 6 times arc sine of u from 0 to 1. Inverse sine of 1 is pi over 2. Inverse sine of 0 is 0. So 3 pi. So we get the same answer as the other situation. Number 8, y equals e to the rx. Y prime is r e to the rx. Y double prime is r squared e to the rx. Y double prime plus y prime minus 6y is r squared e to the rx plus r e to the rx minus 6 e to the rx equals 0. Factor out e to the rx. R squared plus r minus 6 equals 0. This factors in r plus 3, r minus 2 equals 0. Don't worry about that. That cannot be 0. So r is negative 3 or 2. Number 9, write this as dy dx. Multiply both sides by dx. And we integrate. Y plus ln absolute secant y is 2x plus x cubed over 3 plus c. Done. Number 10, x is cosecant is 1 over sine t, but that's y. So x is 1 over y, or y equals 1 over x. If I plug in pi over 2, I get 1, 1. So open circle at 1, 1. If t is near 0, y is also near 0, x goes to infinity. So the graph of y equals 1 over x, only for the part that we consider, is right here, and the arrows are going that way. 11, dy dx is dy dt divided by dx dt. dy dt is 5 cosine t. dx dt is negative 4 sine t. This comes out to be negative 5 fourths cotangent t. D squared y over dx squared. I differentiate this with respect to t. That's going to be positive 5 fourths cosecant squared t divided by the original dx dt, negative 4 sine t. So that's negative 5 over 16th cosecant cube of t. Number 12. Polar graph. R equals 1 minus 2 sine theta. Maximum R is 3. That's the 15th circle. So R equals 1 is 5 circles. So R equals 0.2 is 1 circle. That's what we have. So here's my table. Plug in 0. This is 0, 1. Also 2 pi. Also pi. Plug in pi over 2. Get 1. 1 minus 2 is negative 1. 3 pi over 2. Negative 1. 1 minus 2 times negative 1 is 3. Plug in pi over 2. We already got that. Pi over 4. Radical 2 over 2 times 2. 1 minus radical 2. Negative 0.4. Also negative 0.4. 5 pi over 4. Negative radical 2 over 2. Double negative. 1 plus radical 2. 2.4. 2.4. I want to know when this comes into the pole. Set this equal to 0. Sine theta is a half. So theta is 5. It's pi over 6 and 5 pi over 6. So here we go. So when theta is 0, r is 1. Come into the pole at pi over 6, 30 degrees. And then at 45 degrees, I'm at negative 0.4. Pi over 2, negative 1. So I walk backwards. 3 pi over 4, I walk back to negative 4. Come back to the pole at 5 pi over 6. When I reach pi, I'm at 1. The rest are all positive. 5 pi over 4, 2.4. 3 pi over 2, I'm at 3, the 15th circle, which I only reach once. 7 pi over 4 back to 2, 2.4, and then back home at 1. So this is the graph what I want for that one. 13, summation of 1 over radical n cubed minus 1 compared to summation 1 over radical n cubed. That's 1 over n to the 3 halves. Take the limit of the ratio, multiply top and bottom by radical n cubed. So I have limit n approaches infinity of n cubed over n cubed plus 1. Divide top and bottom by n cubed. limit n approaches infinity of 1 over radical 1 minus n cubed. This approaches 0, so I get 1. So therefore, whatever happens to one happens to the other. What happens to summation 1 over radical n cubed? That's 1 over n to the 3 halves. That converges because it's a p series, where p is 3 halves, which is greater than 1. Therefore, the original series also converges by limit comparison test. 14, I'll do the ratio test. Absolute value of a sub n plus 1 over a sub n. 5 to the n plus 1, x plus 1 to the n plus 1 over radical n plus 1. Flip the original. So I get radical n over n plus 1, 5, x plus 1. So when n gets super big, this approaches 1. So this approaches absolute value of 5 times x plus 1 as n approaches infinity in absolute value. That means this, for the convergent case, this is between negative 1 and 1. Divide by 5, subtract 1. X is between negative 6/5 and negative 4/5. So the radius of convergence is 1/5, centered at negative 1. We already knew we're centered at negative 1 at the start. So absolute convergence here, divergence here and here. Check these two separately. So plug in negative 6/5. I get 5 to the n times negative 1/5 to the n. That's negative 1 to the n over radical n. That converges by the alternating series test. Alternating terms decrease in absolute value and approach 0. If x is negative 4/5, I get 5 to the n times 1/5 to the n over radical n. That's 1 over n and a half. That's a divergent p series. P is a half, which is less than 1. So r is 1/5. Interval of convergence is negative 6/5, negative 4/5. 15. Write as 1 over 1 minus a negative x to the 5th. So the a, the first term is 1, common ratio is negative x to the 5th. So I have 1 minus x to the 5th plus x to the 10th minus x to the 15th. Integrate x minus x to the 6th over 6 plus x to the 11th over 11 minus x to the 16th over 16. Plug in 0, you get 0. Plug in 0.1, 0.1 minus 0.1 to the 6th over 6 plus 0.1 to the 11th over 11. Okay, that's a alternating series. Terms decrease in absolute value and approach 0. Therefore, the series converges by the alternating series test and by the alternating series estimation theorem. If I stop anywhere, there is no more than the next term. Well, this is already smaller than 10 to the minus 6. We want accuracy to 6 decimal places. This is 10 to the minus 6, and I'm dividing something by that already. So this is already less than 10 to the negative 6. I just need the first term to 6 decimal places, so 0.10000. Right, so those are the solutions to final exam of Calculus 2. That's the end of the course. Hope you enjoyed the course. Everybody have a great holiday season and a happy new year. Okay, so bye everybody.